Welcome to BTEC Revision. In today's lesson, we're looking at resistance. By the end, we should be able to calculate the resistance, voltage, or current in a circuit. Let's start off with voltage, which is the energy per unit charge. And looking at this diagram here, we can see that we have charges moving around in this circuit, and each of these charges is carrying a certain amount of energy, which can be used to transfer energy from the cell to a component. The unit for voltage is volts, which we can use the letter capital V to represent the unit. Another name for voltage is potential difference. For our specification, we can use these two words interchangeably. Voltage is potential difference. Now we can move on to resistance. What is resistance? It is the degree to which a circuit or component opposes the current. So basically, it is how difficult it is for these charges to get through the circuit. A connection between current and voltage was discovered by someone called George Ohm in the 1800s, who was a German physicist and maths teacher. He discovered that voltage is proportional to current, and this is known as Ohm's law. And if we multiply by a constant, this would give us the equation voltage is equal to current times a constant. And rearranging this for the constant, we'll name it resistance, which will give us the value voltage divided by current, and that's equal to resistance. So resistance is a constant. But how do we get the values we can use to measure current and voltage? We can use something called an ammeter to measure the value for current, which has the symbol A with a circle around, like so. And voltage, we can use a voltmeter to measure voltage, which has the symbol V with a circle around it. Looking at the units here, we have current, which is measured in amps. If you remember from last lesson, that would be capital A, and V for volts. So resistance can be measured in volts per amps, and it has also another unit called ohms, which has this Greek letter omega. This is the Greek capital letter omega. The short form is R equals V over I, where R stands for resistance, V for voltage, and I for current. Now let's look at an example here. A new LED was added into a circuit, and the voltage across the LED was measured to be 2.8 volts. The LED itself had a resistance of 18 ohms. Calculate the current that transversed through the LED. We can start by writing down our equation. R equals V over I. Now we need to rearrange for current, so we would multiply both sides by I and divide both sides by R to give us I equals V over R. And now we can plug in our values. Voltage is 2.8 and resistance is 18. Plugging this into our calculator, 2.8 divided by 18 gives us a value of 0.15 recurring. So we'll just write that as 0.156 amps. That's to three significant figures. Now let's look at a second example. Lisa is trying to determine the resistance of a wire using a voltmeter and an ammeter. The measured potential difference across the wire is 2.3 kilovolts, and the current flowing through the circuit is 30 microamps. Calculate the resistance of the wire. So the first thing we can note is the units. We have 2.3 kilovolts, which is times 10 to the power of 3 volts. So we can write this as 2,300 volts. The next thing is the current, which is 30 microamps. Micro is times 10 to the power of minus 3. And that unit would be amps. Now we can calculate the resistance. R equals V divided by I. We can plug in our values. So that's 2,300 divided by 30 times 10 to the power of minus 6. And plugging this into our calculator gives us a value of 7.67 times 10 to the power of 7. And the unit is ohms. Now pause the video here and attempt this exam question. A student set up the circuit below. Calculate the potential difference in the 100 ohm resistor when the current reads 0.1 milliamps. So we can start by writing down our equation, V equals I times R, and we can look and convert the unit. Milli is times 10 to the power of minus 3. So the current is going to be 0.1, and milli is times 10 to the power of minus 3, times by the resistance of 100. And that will give us a value of 10 times 10 to the power of minus 3 volts. And we can also write this as 0.01 volts. The next question is, what happens to the potential difference in the 100 ohm resistor when the wire is cut? When the wire is cut, the charges have no path to travel through. Therefore, the potential difference is going to be 0. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions, and there's lots more resources at btechrevision.com. See you next lesson.